Good morning, everyone. Today we are going to continue with our chapter 1 of Science 1, that is laws of motion. So, up till now, we had talked about velocity, distance, time, acceleration, and all those things. A variation of velocity with change in direction, or acceleration. We have studied about positive, negative, and zero acceleration. Now in this topic today we are going to study four things. So we are going to study about distance time graph for uniform motion, distance time graph for non-uniform motion, and then velocity time graph for uniform motion, velocity time graph for uniform acceleration. So these four things we are going to study. So we need to recall that what is a graph first. You just take some time to recall that what parts are there in a graph, how do we draw a graph, what are x-axis, y-axis. So just recall that things, origin, those things, and we continue with this topic. So the first is, now why do we are studying these graphs? So that we can relate them with some changes in speed or velocity, or we can answer the questions. So this is the applicative part of whatever we have learned till now. Means whatever the distance, time, displacement, velocity, speed, acceleration, these topics we have studied. Now we have to apply them, we have to make questions of them. What kind of questions can be asked? So we can ask that what is the relation between distance time graph if we draw a graph and we plot time on x-axis and distance on y-axis. So what will it give you? How will be it? So here is some data given here. So in this table you can see that, okay, in this table you can see that some data is given. Times 0, 10, 20, 30, 40 means there is a difference of 10 seconds. The time is increasing from left to right along. So time is plotted on the x-axis. Then on y-axis there is distance in meters, that is first 0, 20, then 15, then 20, then 30, then 45, and then 60. Accordingly there is a difference of 15 meters after every distance. So now in this graph we have taken a scale of 20 meters distance after 1 centimeter. Means 1 centimeter is equals to how many how many meters there will be? 20 meters on y-axis, and on x-axis 1 centimeter is equals to 10 seconds. So this is about scale of this graph. Let's draw this. After drawing this we find that we get a straight line. Now how do we plot a graph? This is a part of mathematics, so we will not go into the deep of it. Just remember that we check the x and y coordinates. So for example, in this table x coordinate is 0, 0, okay, y is also 0. So the first point will come at origin here. This is the first point. So second point, that is 10 and 15 on x-axis. 10, where is 10? Here is 10 on this axis, and where is 15? Here is 15. So we join a line here and we get a point. So this point is our point, so our second coordinate. In this way we keep on plotting the points. So after plotting the points, if we join them, you find that a straight line passes through the origin. So what do we conclude from that? There are some questions that have been asked in your book about this graph. So there is a question that is the distance time graph above? What does the slope of the straight line indicate? So before that there is one more question, I think. So on the basis of this we can define that an object in uniform motion covers equal distances in equal interval of time. Thus the graph between the distance and time is a straight line. Now why do we are getting this line a straight line? Because the object is in uniform motion, or the car is in uniform motion, because it is covering. Why do we are saying that this is in uniform motion? Because it is covering equal distances after equal intervals of time. What do you mean by uniform motion? It covers equal distances in equal intervals of time. That is, after 10 seconds it covers 15 meters, and then after 20 seconds, that is a difference of 10 seconds, again it covers again 15 meters, it means it is covering equal distances in equal intervals of time. So it is in uniform motion and it is a straight line. Now let us answer the question. It is a question of use your brain power on page number 6 of your textbook. So slope. Now what do we mean by slope of a, suppose this is a straight line. Now what do we mean by slope? Slope of a line can be determined by using a formula. So first of all, consider 2 points on two of the coordinate systems of this graph and note down their coordinates, x coordinate and y coordinate. So x coordinate of this point, suppose this point is a point and this is our b point. So what are the coordinates of a point? So on x axis it is 30, on y axis it is 45. Let me check first. 30, 45, yes, it is 45. And for this second point, that is b point, similarly we will find the x and y coordinates, that is 20 and 30. So these are the coordinates, x coordinate, y coordinate we have. Now what is the formula of slope? Slope is equals to y2 minus y1 upon x2 minus x1. Suppose we consider this first point and its coordinates as x1 y1 and consider this second point and its coordinate as x2 y2. Okay, so we need to calculate the slope by using the formula y2 minus y1 divided by x2 minus x1. Now if we put on the, now what are these s, instead of x2 y2 minus y1 we can say that these are the distances traveled, and x2 minus x1, x2 and x1 here is the time travel. So we put directly here s2 s1 and t2 t1. s2 s1 is here displacement, s is denoted for displacement or distance, okay, in general displacement. So s2 or x2, no, in mathematics we use x and y coordinate. In this science concept we are using s2 s1 and t2 t1. So what will we find if we put the values? Now here he has taken some different points in this example. So he has taken 90 meter and 50 meter example, 90 and 15. So he has taken the sixth and the, he has taken this point and this point. So in this way he has calculated the slope. So accordingly, if you find the coordinates of those points, you will find this and put it in this formula, and you will find that it is 75 meter upon 50 second, and after calculating it you can find it as a 1.5 meter per second. This is nothing but the velocity or speed of that motion. So through this graph you can calculate the velocity by through the slope. If you ask the question for 1 mark in your exam or 2 mark in your exam like this, you can answer that we can calculate the velocity of the car through the slope of the straight line obtained in the graph. Okay, so this was about distance time graph for uniform motion. Now what about distance time graph for non-uniform motion? If we talk about non-uniform motion, the speed is changing invariably. For example, observe this data in this table. So the time intervals is same. In equal intervals, unequal distances are being covered. Just carefully observe the table and data, that the distance is being covered non-uniformly. So the motion is non-uniform. Now if you try to plot the graph, distance time graph for this kind of motion, what will we get? So again, on x-axis there is time, on y-axis there is distance. We will plot the points, and if we join the points you will find that it is not a straight line, it moves like a curve. It is a curved line. So in this way we can say that it is a non-uniform motion because it is not a straight line. So what do we conclude from this? There is a question asked in your book. What is that question? What difference do you see in the distance time graphs for यूनिफॉर्म एंड नॉन यूनिफॉर्म मोशन, क्या डिफरेंस है इनमें दोनों में? व्हाट इज द डिफरेंस बिटवीन द टू ग्राफ्स? फॉर यूनिफॉर्म मोशन डिस्टेंस कवर्ड इज डायरेक्टली प्रोपोर्शनल टू द टाइम for uniform, and non uniform it is not so. Means how much distance will be covered, or it is dependent upon time taken for the motion. In case of uniform motion, if there is a uniform motion, we can say that in a particular interval of time this particular distance will be covered. We can easily predict that for the upcoming path. But in case of non-uniform motion, you cannot predict that what will be the distance covered in the upcoming 10 seconds. If we want to know what will be the distance covered after upcoming 10, means after wait 50 seconds, if there is one more point, if there is, so what will be the distance there covered? So you cannot predict that. So this is the difference between uniform and non-uniform. Okay, now we will talk about velocity time graph for uniform velocity. If there is a uniform velocity, means a constant of, if a train is moving with a uniform velocity of 60 km/h, so what will happen here? Here are some questions. With the help of the graph, how will you determine the distance covered by the train between 2 hours? Means suppose यहाँ से लेके यहाँ तक हमने बात करी 2 आवर्स से लेके 4 आवर, यहाँ पर कितने आवर्स कवर हो रहे हैं टोटल? 2 से 4 तक 2 आवर्स कवर हो रहा है. तो 2 आवर्स में अभी देखो यहाँ पर इसकी लाइन कैसी मिलेगी? अगर आप ग्राफ प्लॉट करोगे, हाउ विल यू, इफ़ यू प्लॉट द ग्राफ यू विल गेट अ स्ट्रेट लाइन, बिकॉज in this graph we have plotted time on the x-axis and velocity on the y-axis. So initially if you observe at the first second it is 60 km, and at the second it is again 60 km, and agar third hour, it is not second actually, the time is in hours, so third hour again 60 seconds. So graph is a straight line like this. Okay, so this is about the graph. Now how will you determine the distance covered between the train, covered by the train between these 2 points, as I have marked here? So distance you will be calculating by a formula. So distance or displacement, for example, for the formula for calculating the distance or displacement of an object, we have a formula: velocity is equals to displacement upon time. Now we have time, we know the time and we know the velocity. So if we rearrange the formula, the t goes on the left hand side and it multiplies. Suppose it is, as it is in division on right hand side and it goes on left hand side, so it will go into multiplication. So s is equals to v upon t. This will be the formula where v is the, s is the displacement or distance, v is the velocity, t is the time taken. So velocity is 60 km/h, as we know that. Just what is the time taken? It is 4 hour minus 2 hour, that is 2 hours. So if you calculate that, we will find the displacement or distance covered will be 120 kilometers in 2 hours. One more logic is there. Without taking into so much calculations, we can simply say that if you are traveling with a speed or velocity of 60 km/h, how much distance will you cover in 2 hours? 1 hour 60 km, 2 hour 120 km. Simple calculation it is. But okay, we have calculated it through the graph. So now next, what question is asking here? Is there any relationship between the distance covered by the train between 2 and 4 hours and the area of quadrangle? So there is a quadrangle drawn here between these 2 points. Quadrangle means which has 4 points. It might be any shape, square, triangle, trapezium or random shape, but it must have 4 vertices. So it is called as a quadrangle. 4 vertices or 4 angles, it is called a quadrangle. Quadra matlab 4. So is there any relationship between the area of this quadrangle and the distance covered? Yes, there is a relationship. We will discuss about it. What is the acceleration of the train? This is also calculated here. So if we calculate the area of ABCD, if you observe this, ABCD is a rectangle. What is the formula for area of rectangle? Area of rectangle is equals to length into breadth. So what is the length of this? 4 into 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 rectangle, that is AC. What does AC represent? AC represent the velocity of the train, that is 60 km per hour, and breadth is here AB, and AB represent the time, that is 4 minus 2, that is 2 hours. So we have time 2 hours and velocity. So we put this in the formula. Again you get 120, and it is equal to the part 1, that is distance. So we can say that area of that quadrangle is equals to the distance traveled during this time interval. Of course we can say this. And acceleration of the train here is 0. What do you mean by acceleration of the train? Acceleration means, what is the definition of acceleration? Change in velocity upon time. Now what is the change in velocity? Is there any change in velocity actually? If you observe between these 2 points, the velocity is constant. We have already said that uniform velocity. At both the points velocity is same, that is 60 km per hour. So if you subtract the initial and final, that is v, that is final minus initial, v minus u, v is 60, u is again 60, 60 minus 60, 0, 0 upon time travel 2 hours, 0 upon 2, it is 0. So acceleration will be 0. So this was about this graph. The next graph that we are going to study is velocity time graph for uniform acceleration. Now that data is given here is different. Velocity is changing, velocity is not constant. Previously what we said, velocity is constant and time is changing. Now both the things are changing. Velocity is also changing, time is also changing, but what difference is there? Difference is that velocity is changing constantly. If you observe the difference between these two initial points, that is from 0 seconds to 5 seconds, the difference is 8, again 8, again after that, after next 5 seconds it is again 8, means the velocity is changing with a constant value, that is 8 meter per second. Okay, so velocity changes constantly. There is a, it is, we can say that it is a uniform accelerated motion. Now why do we need to observe this graph? We need to observe this graph to observe some things. So these things are, the velocity changes by equal amounts in equal intervals of time. Of course we have seen that. What is that difference? The difference is of 8 meter per second, if you observe the data carefully. So how much does the velocity change in every 5 minutes? Okay, 8 meter per second. This is the answer of this question. For all uniformly accelerated motion, the velocity time graph is a straight line. As you have observed, uniformly accelerated, if you plot a graph, it is a straight line. Now for non-uniformly accelerated motion, the velocity time graph may be any shape. So if the velocity is changing but it is not changing by a constant number as it is changing in this case, what will be the graph? So graph might be any shape. It might be like this, 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 any shape depending upon the what kind of change is there in the acceleration. Where the point goes, we will meet them. So it is dependent upon the acceleration changes with time, depending upon the change in acceleration with time. So in this graph, the question has been asked, in such a case we have to use the average velocity of the car is given. So if you want to, from the graph in figure 1.8, we can determine the distance covered by the car between 10th and 20th second. Now here it is asking that what will be the distance covered between this 10th second and 20th second. Is there any relation? Can we find that? So there is an answer for this. So what is the formula for velocity? Again the same formula we will use here. Velocity is equals to displacement upon time. We need to calculate displacement. We know time, we know velocity. So the velocity is not constant here, it is changing, but it is changing with a constant value. So we can take here the average velocity. So what is the average velocity of the 2 points? The velocity at this final point is 32 meter per second. At this A point it was 16 meter per second. So if you take the mean of this, that is 32 plus 16 divided by 2, it is equals to 24 meters per second. This will give you the average velocity. So to calculate the distance traveled or displacement done in between these 2 points, in between these 2 intervals of time, you use the formula S is equals to V into T, where V is the average velocity, T is the time taken. So V we have calculated, that is 24 meter per second, and time is 10 second. Okay, so if we multiply them, 24 into 10, that is 240. So this is the distance covered between these 2 points. How do we get this? We get this from observing the graph only. So this is the application of this concept. So now what, again one more question is asking here, check that similar to the example of the train, as we have observed in the case of train, is the distance covered is given by the area of the quadrangle. Is there any relation between the distance covered and area of this quadrangle? Which quadrangle? This A B C D. Observe this quadrangle first. So this is not a particular kind of shape, as in our case of previous example there was a rectangular shape, so we directly calculated the area of that quadrangle by applying the formula of area of rectangle. But this is not a defined shape, so we can divide it into 2 parts. So this is the first part, AECD and ABC triangle. So we can say that the area of quadrangle ABCD is equals to area of this rectangle or square AECD and plus area of this triangle ABE. So if you add the areas of these two figures, you will get smaller figures, you will get the area of bigger figure. So you can calculate this area by this formula. So in this way, area is equals to, again, okay, what has happened here, wrong, okay,